we have this concept of software-defined hardware. You can apply it from lots of different applications. In this case, it's conferencing. It allows customers to actually say how many I2S interfaces, how much I2C interfaces, literally define their architecture.
It's Eamon at ipXchange at the XMOX booth at Embedded World 2023, second day. I'm here with David, and we're going to talk about this. Yes, so this is a AI multi-channel audio platform. So very interesting stuff.
Yes, it is. Okay, so this is the XVF 3800. It's our latest generation of voice processing pipeline. So this is aimed at conferencing applications. So imagine you're in a room, like a standard conferencing room. You've got 10 people around this table. You've got some people who are probably quiet, sitting quite far away, some loud, like myself, who is actually quite close to the thing. So it's overloading it. So you've got this, and also the device has then got a speaker. So the speaker's actually playing out. And what you're trying to do is so you've got lots of problems there. So what we've got is, like, you can't see this on your video. We've got a voice processing pipeline that's aimed at getting rid of those sort of noises. So the key thing is you've got like all these people in this room. This is called the near end, and you've got all the people in the far end who are listening at probably on a Teams or Zoom call. Okay. So the idea is they need to hear clear speech. So the key thing here is that this algorithm here is trying to provide the best clarity that you can get out of that really difficult situation.
Cool. So does this board kind of deal with kind of deverbing and that kind of stuff?
Exactly that. Yeah. So you've got like key things in the pipeline. You've got like you've got an echo canceller. So the echo canceller is the thing that's actually going to get rid of the self-generated noise. So that's the thing coming from the speaker. So also what you'll do is that sound would bounce off all the walls. So you'll have a de-reverb stage. And then obviously you've got other noises within the room. Probably point noises, probably from someone clattering on a table or opening sweets and stuff, which is quite distracting. Yeah. So what we have is like beamforming. So there's 3 beams. It's notionally beams, let's call them a beam, to keep it simple. So basically you've got 2 that would concentrate on 2 talkers in the room, and another which then goes around and then searches for the next talker. Okay. So that's the beamforming. So that's like really solving like the point noise type problem. And then like in here, you've got that sort of stationary ambient noise that's continually going through. It's stationary because it doesn't change over time. That's why we mean stationary. Yeah. So there's another block which actually is removing that as well. Okay. So one of the advantages of our devices in this particular pipeline is that it's got a good AGC, now automatic gain control. Okay. So this accommodates for the situation where you've got someone near who's talking very loud and somewhere far away who's talking quite quietly. So the AGC adapts to that energy level and makes sure that there's consistency for the people at the far end. And the other thing, I was talking to the algorithm designer, or one of the representative of the algorithm company that was actually running on our chip. And one thing he was saying is that what they also do is harvest the energy and use that as opposed to cancelling it out. Nice. So in the situations we've got someone very quiet, far away from the microphones, the reverberation and the general noise is probably louder or as loud as the direct path from their voice. So you've got to harvest every bit of energy, for the far end. I think that's most of the bits in there. So,
So I usually would ask what the sweet spot application for is, but obviously this is conferencing. But can you think of any other applications that you might find this in?
So you're right. This is predominantly aimed for conferencing, but I think some people would want to put it into a video bar. Again, that's probably a conferencing application. So, it's largely enterprise, but I think a lot of people actually want these in their home as well. Okay. With COVID, they're trying to put it into a small speakerphone, and so that would end in a small speakerphone. That might be for a huddle. A really challenging situation is where you put that in the middle of a coffee shop. Okay. And there's a huddle of people around it, so it's got to work in that situation as well. There's lots of different applications for conferencing. Now you can probably use it into other like display applications, probably like in a supermarket or something like that. that's quite challenging. That's very similar to this. But that's really pushing it, but you could probably put it in that as well.
Cool. So if a design engineer was looking to evaluate this technology to put in their own kind of conferencing product, what would be the best way of going about it?
Okay, so the first step is to have like a demo kit like this. So I'm a field application engineer, so I would probably be the first port to call in terms of helping a customer actually work out what it is they want. And then, then we'd probably say, we'd just have a discussion with them, whether it's the right fit.
Yeah.
And then if it is, then we'd say, okay, well, you need an evaluation kit. You want to then plug that into something, probably a laptop, and start doing some evaluation yourself, working through it, make sure it's what you want. And then we can discuss anything about that. We benefit from quite a large team, or a reasonable sized team around the world. So we've got a laboratory in Boston, we've got a laboratory in Hong Kong, we've got a customer application team who's very well versed at solving these problems. So we've been doing this for 5 years now.
Okay.
So one of the key things to trying to get a customer to market is experience, because a lot of people do this. We've got there's the rest of competition out there. Anyone can do an echo canceller.
Yeah.
But to do a really good echo canceller that works, converges quickly, and does all that stuff really efficiently, that's kind of key. That's a differentiator.
Yeah.
And because we've got the experience, and actually it's not just, this is an evaluation kit, but the key thing is you've got to put that into something. And so we can put them into contact with somebody, another third party that can help them to make sure you have a very good enclosure. Because if you've got a poor enclosure, it's going to create non-linearities, and that will come through. So it's very important to put that into something that's really going to work well. Yeah, and we can help them do that.
So I guess in this kind of application, because it's such a sensitive application, you really need the full integration system to be perfect for the application.
Yes, so you do.
So XMOS will kind of help with that, make sure it's really the right fit.
Yeah, exactly.
Oh, excellent.
Yeah, I cover lots of products, so I've got a reasonable amount of experience with this, but then I have colleagues who are really experienced with this, and they have a whole team to help customers, tune the algorithm. There's not a lot of tuning because largely it's self-adapting, but there is sometimes, especially when the customer's putting it into an enclosure, they might not have got the enclosure quite right.
Yeah.
So there is a lot of tuning that comes into that to make sure the whole experience is really great. And as I say, the key thing is intelligibility at the far end. So.
Oh, well, that's a very excellent product.
It is.
So what is this algorithm running on?
Okay, so this is actually running on our latest generation X-Core AI processor. Okay. So it's actually a multi-core processor. So what we have this concept of software-defined hardware. So it's really useful because you can apply it from lots of different applications. In this case, it's conferencing. But what it allows you to do is it allows customers to actually say how many I2S interfaces, how much I2C interfaces, literally define their architecture. So the customer's not paying for IP that they don't need. They're just paying for what's on the silicon, and the customer can choose whether it's actually going to be more I/O or more processing.
Okay.
So, and this particular device here has got a vector processing unit, which allows you to do multiply and accumulates very, very efficiently. So it's got a lot of compute performance. So this algorithm typically runs on quite a high-end application processor. Okay. But what we're doing here is being ported to a very low-cost a microcontroller stroke DSP, effectively.
Nice.
So it's the whole thing. So the whole thing, when customers are considering this, is the total cost of ownership. And that's the chip all the way through the support and everything. So that's what we're offering here.
Cool, excellent. So I like to ask when we're at these big shows, final question is, how are you finding Embedded World on the second day?
It's going well for us. Yeah, we're having quite a few customers coming along and having some good conversations.
Good.
I think we would like it to be a little more busier. Because I'm from sales, so we always like lots of leads. Yes, the leads are the kind of the key thing, but generally speaking, it's going well for us. Thank you.
Good.
Yeah, it's good.
Is there anything else you'd like to add about XMOS in general?
I think the key thing is what we'd really encourage our customers to go to our website. There's a lot of good information on there, white papers and various other things, to give them a good idea of what we're actually doing. From here we've got this X-Core AI device, which is actually using our own proprietary RISC instruction set. Okay. You'll probably see in the corner there, in the future, we're looking at RISC-V.
Nice.
And that's got a lot of benefits that we'll be talking about from our our marketing team will be really putting that out, and you'll be hearing a lot about that in the press coming up forwards. Today we define the architecture. Tomorrow we're deciding exactly what that's actually going to look like in a customer's hands. So.
Cool. So sounds like there's going to be a lot of good stuff in the future
There
for
absolutely is. Yes,
XMOX.
indeed.
And I'm sure we'll see you at another show and try and get the latest on that time.
Great to meet you guys.
Cool. Very good to meet you too.
Take care.
Thank
Cheers.
you.
Bye bye.
Well, that was a fun interview with XMOS. So if you'd like to evaluate some technology that's going to make working from home seem a little bit more like working in the room together, check out the links in the description.